these are the answers. These are the answers for chapter 11 test. And problem number 1. This is number 10. Here we go. Okay, so problem number 1. All you need to do here is you need to use the Pythagorean theorem to find the missing side. So it was a squared plus b squared equals to c squared. So it's a squared plus 12 squared equals to 17 squared. So you subtract 12 squared and then you get the square root. So when you do that, the length of the side is 12.04. You multiply by 2 and that is 24.08. Now notice that that's longer than this one. So it's not to scale, as you can see that. So ACT problems would be something like that, but they'll put here not to scale. Okay, but diagonal 1, diagonal 2, half of that, and that gives you 188 point something higher than 0.5. So when you run it to the tens or hundreds, it would be 289.00 square meters. So that was number 1. Problem number 2. It says a sector of a circle has a central angle of 80 degrees. And the circle has a radius of 5.5 inches. So the measurement of the angle divided by 360 times pi r squared is a formula for the area of the sector. Since the sector has an 80-degree angle, divided by 360 times pi times the radius, which is 5.5 squared, you put all of this in the calculator, and that gives you 21.12 square inches. Now, problem number 3. So in number 3, you need to get the area of the trapezoid. So it's 1/2 base 1 plus base 2, which is 15. And then times the height. The question is, how do I get the height? Well, 6 subtract from 9 is 3. So it's 3 squared plus a squared equals to 5 squared. Then you subtract 3 squared. You get the square root of that. So square root of 16, which is 4. So the height is 4. So that's the height. And then that is the diameter. So half of the 4 is 2. So it's 1/2 times the height 4 times 15, base 1 plus base 2, minus pi r squared divided by 2. And what I didn't do on the first time that I had my answer key is I didn't divide by 2. And that's why my answer was like 40 something. So anyways, the answer is when you subtract 4 pi divided by 2 from 30, which is the answer from here, it's 23.72 square inches. So that was number 3. Now problem number 4, it's 3 shapes, 3 simple shapes. One of them, it's a semicircle. This is a semicircle right here. Then you have a square. Then you have a triangle. So for the semicircle is 1/2 pi. The radius, well, the diameter is 3. So half of 3 is 1.5 square. Plus the square is 3 times 3, so that's 9. And the triangle, the base is 7, the height is 3. So 1/2 base times height. You put all of this in the calculator, and that gives you 23.03. It's 23.03 square units. So that was number 4. Any questions so far? So far, so good? Okay. So problem number 5. In number 5, the shaded region, it's all of this here. So when you get the area of the sector, it's going to be 360 minus 24 degrees, which is this piece right here, divided by 360 times pi times the radius 12 squared. And then just put all of that in the calculator, and you get the 422.23, and it's a square centimeters. And that was number 5. Now let's move on to number 6. In problem number 6, it says find the perimeter and find the area. Well, for the perimeter is just 11 plus 11 is 22. and then 10 is 32. So the perimeter is 32. Now, to find the height, to find the area, you need to multiply base times height. Well, the height, you can find it two ways. You can just say, if this is a 60-degree angle, this is a 30-degree angle. And if this is a hypotenuse, the hypotenuse is twice the short leg. See, across some 30 is the short leg. So half of 5 is 2.5. Then the long leg is a short leg, 2.5, and then times square root of 3. That's one way of doing it. If you decided to use SOHCAHTOA, sure, it could be sine of 60 equals to x over the hypotenuse, which is 5. So it's 5 sine of 60. And if you put this in the calculator and you put 2.5 square root of 3, it's the same value. So base is 11 times the height, which is 2.5 square root of 3, or this number, whichever of the two. And that gives you the 47.6 square meters. On the next problem, problem number 7, this is asking for the base and the height. So what they're saying is, well, first of all, this is a parallelogram. Okay, so the area for a parallelogram is base times height. So they're saying that the height is equals 3 times its base, so it's 3b, and the base is just b. And then when you plug in the height, 3b times the base, b, equals to the area, 972. When you multiply b times b, that is b squared. Then you divide by 3, is 324, and then you get the square root of that. So the base is 18. Then since the base is 18, multiplied by 3, that gives you 54. So the base is 18, the height is 54. And don't forget to put the unit of measure, which is inches. Okay. So now we're going to go to number 8. On problem number 8, they want you to find the perimeter. To find the perimeter, God bless you, you're missing this side over here. Well, that side is the hypotenuse of the triangle outside. So for that, you have to do a squared plus b squared. So it's 8 squared plus 6 squared, that equals to x squared, and the x in this case is the hypotenuse. So 8 squared is 64, 6 squared is 36, and this is a square, so it's 100 equals to x squared, and then you get the square root of that. So x is equals to 10. So either you use a Pythagorean theorem. What I used was the triplets. See, this is a 3, 4, 5 triangle. 3 times 2, 4 times 2, so it's 5 times 2. That's the shortest way to get that answer. So once you get the 10 added to the 4 is 14 plus 12.8, that's the perimeter, which is 26.8. And then for the height, well, it's just 1/2. The base is 4. The height is 8. So it's 1/2, 4 times 8. And that gives you the 16. That was number 8. Okay, now problem number 9. In number 9, they're saying a trapezoid has base lengths, so they're giving you the two bases, of 19.5 and 24.5. And they're giving you the area. So area is 154. So what you do is you find the h by getting rid of all of this here. So 19.5 plus 24.5, half of that, it's 22. Then you divide by 22, and that gives you that the height is 7 centimeters. And that was the answer. Any questions so far? So far, so good. Okay. So let me move on to the second page.